gentlemen, welcome to another energizing episode of the High Voltage Live Show. I'm your host, Willie Snyder with Nat King Code, coming to you live from the Mile High City. Joined with my awesome co-host, Mr. King James Stallcup, over there at Hook'em Horn Country, giving old Hook'em Horns from the Mile High City, representing the Stallcup Electrical Education. And I really had an awesome week this week, man. My stuff keeps getting better every week, and I appreciate your help. Like I say, I usually don't have to, call you in on it, but like I say, I really wanted to try to answer this one the best way I could, and like I say, I think I kind of got a pretty decent angle on it, but what we realize is no post is ever going to be perfect, but look who we got up, and you're right, Daniel. Wes Welker, yeah, the old school Wes Welker, that's it, brother. I
wasn't gonna leave him hanging.
coming for the quiz. Oh, we got a super easy quiz for you guys tonight. It's gonna be super easy. Oh, Mr. E, Electrical Wizardry, how you doing, David? Hopefully you're staying out of those hurricanes, and we've been praying for all the people down there in Florida, making sure they're all safe and stuff.
I was just Asheville. Golly, man, that place got tore to hell, man.
Thanks for smashing that like button, David. Appreciate you.
I was watching the thing, and they were arguing, or going back and forth, I guess you could say, but they're not doing anything to really help the people. They said they haven't seen the federal government, FEMA, National Guard, any of them down there helping or anything. And they're saying now, well, we don't have the funds because we spent it all for all the illegal people that come in. I'm like, you freaking got to be kidding me, man. That's bull. Excuse my language. I was like, it upset me. I was like, why are we taking care of everybody else? We got to take care of our own here. That's why we pay taxes. I mean, 100%. But anyway, I hate to get political on this, but I just heard about it today, and I was like,
we'll try to stay away from that, but no, we really appreciate all the participation. It's been an awesome time, and make sure you guys check out our Monday show too, Monday Morning Coach. It's been a lot of fun. Me and James talk about football. James covered the college side of it. I cover the pro side of it, and Guess whose defense I got this week in fantasy? I got the Broncos defense. They're one of the top ranked defenses.
God, you're gonna lose so many points this next week.
you never know. You never know. It's gonna be interesting. Me and Daniel will be there, man. I'm excited, Daniel. That's gonna be a lot. That's gonna be a good time. We're gonna take the old light rail down there and
that is gonna be fun. It's just like we went to the Texas game, man. I had a freaking blast, down there. Yeah. And we're already talking about the next time we go to the night game so we can hopefully they'll have the drones and everything going. But we had a good time. And y'all are going to have a blast, too. What's the weather supposed to be like?
80s.
Oh, that'd be great.
Yeah. It might be a little windy, but I think maybe that's why they're thinking our defense can have a good day, because it's gonna be, we're gonna have to keep it on the ground. But I had to get Williams in there too, so I got a running back up in my fantasy. But you never know. We'll find out when we come up to do our segment next Monday how good I did, and you can razz me. I certainly don't hold back any punches I do.
Y'all can't razz me because I think I've had, what have I picked? 8 games for, we had the games of the week, and I've hit on 7 of them. And everybody else went against me. Then we've done football where we've done like 4 of them, and I've got 3 of those out of 4. So
yeah,
a pretty good record so far.
I'm one of those people. I set myself up because I always like taking the underdog for some reason, and almost always the favorite wins. So I set myself up a little bit, but that's what I get for agreeing with Daniel. So I was trying to take Daniel with me on my underdog upset, but you killed us 2-0 2 weeks in a row, so it's all good. You know, it's all good fun, and like I said, we were just betting friendly and everything. So,
Okay, who you taking, the Buccaneers or Falcons tonight?
I think I'll take Falcons. I think
Okay,
they've just showed more.
I'm gonna take the Bucks.
Ooh,
I'm
oh,
taking the
good
Bucks.
man. Oh man, wow, really?
There you go. That's way, Daniel. Follow the
All
leader, baby.
right, all right, all right. But I don't really think the Falcons are underdogs though. I think they're favorites actually.
It'll be a good game. Uh, I'm actually gonna watch that tonight. All right, let's kick this thing off. You ready to look at the meme of the week?
Let's do it.
All right, let's roll her down. Let me get over here. There we go.
Oh, I thought about this from like when you were saying that we did a bunch of variations of that same meme, but they all said different things.
That's right.
And I thought about the obvious thing, what the guy's gonna be thinking while this chick's sitting there looking at him, like, I'm not cheating, you know what I mean? Like quit looking at me, quit give me that look, you know. But that was a pretty good variation of that meme that I thought was pretty funny, and of course, stolen from the Wall of Shame show. Big shout out for who I stole that from.
I tell you a true story. Back when I was in my 20s, I was actually going out with two girls. One was named Sharon, and the other one was Charlotte. And I was out with Sharon one time, and I called her Charlotte. And she was, who's Charlotte? And I was like, damn, man, I got caught. So from that point on, I was like, you know what? I'm not even going to lie anymore. I'm just going to tell them I'm going out with her. You can too. And I'm being honest when I say this. They liked me more and wanted me more because I think they thought it was a challenge. I'm serious. And so, I didn't get married till I was 30, but my mom was always, because my two brothers, they're younger than me. They were already married, kids and stuff. And here I am, the oldest, and I'm just running around having a good time. And my mom was always on me. You need to settle down quick, because I was always having a different one all the time. She got mad at me and said, you need to pick one and settle down. And finally I was like, yeah, I guess it's time to quit playing around so much, having a good time. Because I was taking trips to Vegas and going overseas. I was just having a ball, I was making pretty good money. Hell, I was having a good time when I was young. So, but that's what that reminds me of. Yeah, I got caught. I was 20 years old when it happened.
One thing I want to say is big shout out to everyone who participated in Nat King Code Myth of the Week this week. I had record numbers. I cracked over 100,000 this week, and it was awesome. I couldn't have done it without you guys, and it meant a lot that I'm trying to kind of elevate my posts to kind of like get in that wheelhouse of like where people are asking these questions and kind of keep elevating them a little bit every time so that, I get like an actual question for King James that is, kind of like a little bit more advanced. So hope you guys like the Myth of the Week. Let's roll it.
Do it up.
It's time for Myth of the Week.
All right. Well, this came up on one of the job sites we were at, and I was telling about the Myth of the Week, and the foreman that I was working with, he goes, what? He goes, you do that? He goes, you just like ask any question? And I was like, yeah, and he goes, man, I was arguing with this guy about the whole entire circuit has to be that size, So, Myth of the Week number 132, true or false, a 120 volt circuit with 2 light poles with a total load of 3.77 amps, a total circuit length of 317 feet. Number 10 AWG needs to be installed for the entire circuit length to ensure the circuit's performance below 3%. And I'll tell you right now, that is 100% false. You could actually pull. I actually took this picture as kind of like a joke. I found it on Google Images, and the caption was, "You had one job," and they put both light poles right next to each other. So obviously that's not right. But it was a good illustration for what I was trying to show, that you're going to be bringing that number 10 out to that first pole, and then you could probably run number 14 from the one pole to the next, so it was so close to each other. But that's what kind of busts this myth this week. A lot of people think, like, once you do that calculation, it comes up, it says number 10 AWG, then they say everything needs to be number 10 AWG. But me and King James are just talk about this, like, you could take and go number 16 from the base of that pole all the way to the head, and that's totally fine, and you've already accounted for your voltage drop. But like I say, this one's pretty interesting because a lot of people don't know that voltage drop calculation is factoring 1,000 foot into it, and we actually busted that myth as far as the rule of thumb that you have to factor in voltage drop after 100 foot. And the reason why is because that ampacity table that's in the code book is based on 1,000 foot. So we have to do the adjustment based on that ampacity. Obviously, if you have, let's just say, number 12, and you say, okay, 20 amps, once you get outside that 100 foot, you're going to have to start adjusting. And, you know, given, I don't think there would be too much issues if you ran number 12 with a 3.77 amp load. I think it would probably push you into like the 4.2% range or something, which is still allowable for a branch circuit. So I don't really see any real world issues, but a lot of people come into these groups and say, oh no, you have to run number 8 to that. Well, why? It's overkill. Right now we're at like I think it was like 2.67 or something percent voltage drop. So you're well under 3% with this draw. And like I say, I kind of already talked to you about it, James, and as far as how I wanted to roll it, but that's kind of the gist of what I was trying to get at.
Yeah, I didn't do the calculation either. And let me just sort of explain something here. And I will go back. We'll do another one on this, because when you put this myth of the week, I actually had somebody message me, and they said, didn't you take, they said, it's been like a couple of years ago or something, didn't you explain about voltage drop and all this stuff? And I replied back, I said, yes, I did. And I said, we actually went over and we showed the way they used to look at it based on different conductor sizes. And I said,
right,
you know, some of them you would look at, they would tell you at like 45 foot you need to start. But when they did that, that was for solid conductors. And then
true,
when they started doing the new tables, and this comes from the old school, from what I was taught, you know, listen to Dad and a few of the other instructors out there, when they developed table 310.16 and started working on that with the new conductors and everything, the rule of thumb was once you get at 100 foot or more, you want to start to consider for both all conductors.
Right. And if I remember correctly, the one we covered on voltage drop was if stranded was a better conductor for voltage drop, like is. Stranded versus solid. And didn't we find out that solid was actually better for voltage drop?
It is for voltage drop, but you gotta start doing it quicker than you do for stranded, and
Gotcha.
that's the difference. We're stranded. We didn't really. They just basically said for all the conductors that are listed there, the rule of thumb was at 100 foot. You wanted to start looking at voltage drop, but I went back and I was looking in the McGraw-Hill book, because Kyle, man, I have to go back, see how far we actually go back. We got books back from the 40s and 50s in our library, and I pulled information out of there showing where they were doing the solid conductors, but you had to start considering voltage drop at you couldn't go up to 100 foot, and all the conductor sizes were different in different lengths that you started considering voltage drop. So wow. I will have to go back. I'll do one on that, because when I did that, I actually did some calculations and stuff, and I think we spent about 30-40 minutes going through all that and explaining all the options and stuff that were there. So I will go back. I'll do that again, because I asked the guy replied back to me and asked me if I'd do it again. He said he was having trouble finding it, and I said, okay, yeah, I'll do it, but I won't do it until after I get through these 2026 changes. So
but we're almost there, aren't we? Like,
I'm in chapter 7 now. I'm thinking there's about another 2 weeks, maybe. There's been a lot of changes in chapter 7 that are being addressed. So I'm not sure. I'm pretty close to about a quarter of the way through it. So of all the articles that are there. So I figure, depending on how many are next week and the next, I could be done here in a week or 2 or 3 weeks. I just haven't got to them all yet.
Didn't we find out that like the solid was better at like the smaller gauges?
Yes, but you had to start doing the voltage drop calculation sooner, based on the footage. So like we may have had a number 12, you had to start doing it at like 65 foot. I don't remember the exact distance that was there with the stranded. We did it at 100 foot.
Right.
That was the difference in them. So but I'll go back and pull all that information up. Mainly everybody uses stranded anyway now, so solid, I mean, you don't see it used that much anymore. So but we will be the hard-hitting podcast that goes back and shows you all of that stuff. So and that's one of the good things about this podcast. You know, I'm fortunate that I pull over, you know, God, I guess Dad, he's been doing it. He probably started in the
70s.
No, he started in the 60s when I was born.
Oh,
so he started
60s?
He started in 64. Yeah.
Oh,
so
wow.
You're looking at 50 years experience there, easily as a master. So let's see, 64, 84, 94, 2004, 2004, 60 years.
Oh, I thought you were talking about writing the publications.
The publications, he started writing those.
Like the 70s, wasn't it? Early 70s?
It was late 70s, because I graduated in 82. So he had started, he actually was writing his own material in probably the mid 70s, where he was teaching them. Then American Tech picked it up, and I think it was from that point. So you're probably looking, I was probably a freshman. I remember him at the bar working on them. So 78 at least. Yeah. So, I'm about to show all that. When you get in, you start looking at these calculations and everything. You know, and some will remember this. If you go back and you look at where we're applying Ohm's law and pi formulas, the last portion of that for that journeyman and master ceramic exam that I did. You went in there and you picked that up, and we actually go over the voltage drop for a single phase, three phase, and then we actually show you how to do the calculation based on just circular mill. So we show you 3 different calculations there. And when you look at 210.19, this used to be 1910.A3 informational, and they moved it this last cycle, I think it was, up into 210.19 as an informational note. And they talk about how to do the voltage drop. Now, of course, some will argue, well, voltage drop don't apply because informational note's not enforceable. Well, I'll tell you this, if you don't apply the voltage drop and that light's out there is dimming, they're going to want to know why. And dude, I will.
We actually have a joke about that where we're like, could you imagine if you started like quoting all these like code references and you're sitting there walking inspection with like the inspector, like every time the AC unit turns on, the lights dim, and you're like 90.1.
That's an informational note. That doesn't apply. Yeah. I mean, they'd be like, the hell it doesn't. And I'll tell you this, from an engineering standpoint, they will take voltage drop into consideration.
And David says, okay, true. Also, not to forget what the energy code requires voltage drop. Yeah, that's a good point, David. They just added that too.
Yeah, voltage drop is important. You got to consider it. And usually what they'll do is, let's just say that I was over here at some switchgear and I come over here to a panel board that's 200 foot away. They'll usually take for that feeder and put it at 2%. And then anything that leaves there as a branch circuit from that panel board that gets over the long distances, then they'll put 3% on that, because you can't exceed 5% overall. Right. Okay? And that's what 210.19 informational note and 215.82 informational note number 2 tie in together. And then if you look at note or informational note 3, it refers you back to look at the informational note in 210.19 for the branch circuit to make sure that you don't exceed 5% overall. Now, the calculation I always tell everybody to use, especially if they're doing the testing and stuff, I tell them to take the voltage drop, and I'll tell them to take it like this. You'll take 2, which is a constant. Then you'll take at time L, which is the length of the conductor, time R, which is the resistance of a conductor, time I, which is the amperage, and then you divide that by 1,000. Okay? Right. That is a normal calculation. So when you get over here and you start looking at these different things, I actually put the wrong table in there. God dang it. What I meant to put in there was chapter 9, table 8. I put the wrong one. I don't know why I did that. I was late. But when you go in and you start looking at chapter 9, table 8, you're going to go in, and usually what you'll see on the test, they'll have an uncoated wire. And you come down the uncoated wire section there and come across, pick your conductor across, and that'll tell you what the resistance of that wire is that's inserted into the calculation. Then once you do the calculation, you're trying to make sure when you do that calculation, if you're doing it for the branch circuit, it's below 3%. If you're doing it for a feeder, it has to be below 2%. Okay? Now, you could take and do the feeder at 3%, but then the branch circuits are 2%. Okay? So depending on how you set that up, that's how I would look at doing that calculation when you're dealing with voltage drop. But back to the other question is, if I go out there to a pole and I go out there, that's a branch circuit, I'm going to put 3% on it. All right, let's just say what'd you have, 300, let me go back and look. You had 300 and something foot there, 318, 319.
317.
317. So you had 317 foot. So you're doing the calculation. Now, once I go to that pole and I size that conductor, if I go to another pole, say it's 150 foot away, then you're going to do another calculation based on 150 foot. Okay. Gotcha. Then you may go to another pole from that one that's only 50 foot away. Now you don't even worry about voltage drop. But the rule of thumb is always this: when you're doing the calculation for the voltage drop, you want to do that when it's based on any conductor length over 100 foot. That is the rule of thumb that you want to look at. Okay?
Yeah, and like I say, when we first started doing this, King James started bringing out all these thumb rules, and dude, there's some good thumb rules, man. Like he went and literally tested all the math in the whole entire code book, and he could tell you which one if you're at 125%, you go up to the next standard size. If you're over 125%, you go down to the next standard size, unless it's phase converters and transformers, right?
Well, you know what gets me is they argue with me over this, and even Ryan Jackson, he put a video out to show I was wrong, but at the end he agreed with it.
Right.
I mean, he goes, but why wouldn't you just go up to the next standard size? Well, maybe because the breaker's cheaper and you're permitted to do that if it'll allow the motor to start and run. And you cannot argue what it says. If I'm gonna put this out so everybody understands, and I'll just do a problem off the top of my head here. Let's just say that I'm going to size an inverse time circuit breaker, just a regular circuit breaker, okay? And let's say I have a 50 horsepower, let's say it's 460 volt, 3-phase design B squirrel cage motor, okay? Now,
460, 480, whatever it takes.
Yeah, 460, 480. Now, this is interesting. If you go look at section 240.4G, okay? Now, when you go pick up that section right there, you're going to go down and you're going to pick up the table, and it'll say specific conductor applications. Okay. Now, why is it specific? Because when you go in and you start looking at those are going to be higher percentages for sizing the overcurrent devices for the conductors. This means you're going to have larger overcurrent devices. And when you go look at your motors and stuff, it'll say Article 430, and it lists all these different parts. Okay. Now, when you go look at 430.6A1, it talks about your table values. And basically what it says is this: anytime you're sizing your conductors or overcurrent devices, you're going to do it based on the table values in tables 430.247 through 250. Okay. Well, right. Anybody that's been doing this for a long time, this is pretty simple. If it's a 3-phase motor, I got to look at table 430.250. And if I come down, pick up a 50 horsepower motor, come across, pick up 460 volts, it's going to tell you it's good for 65 amps. Okay. Now, this is what, and when I've been teaching classes all these years, I used to have them put certain things in their code book, and I would tell them right above this table here, what I would take is I'd put conductors, and I'd say you need to put these sections. You need to put 430.22 and 430.34 for 2 or more motors. Then when you're sizing the overcurrent device, I'd have them put OCPD there. I'd say 430.52C1 and 430.62A for 2 or more motors. That's something I always taught. This is, right. Because if you go and look in our publications, you look when we do our online training stuff, I always provide code loops. These are the steps you want to go through in order to do a calculation correctly. Now, since I'm doing a single motor and I go look at 430.52C1, the heading literally states in accordance with table 430.52, and then you go pick up the text right below it. It says it shall not exceed the calculated value in table 430.52C1. It's C1 now instead of C. So C1, you go pick up that table. And now, let me say this. It says it cannot exceed the calculated value. If it can exceed the calculated value, that means you're going to drop down to the next standard size.
And what's that calculated value based off of? See, that's my whole point, right?
Well, it's based on the percentage that's in the table.
Yeah. But it's not the maximum percentage, it's based on the percentage.
That's right. And in our publications, we put it as a minimum, as a starting point. You can go lower than that if it allowed the motor to start and run, but you got to have a starting percentage based on the code. Okay. And then once you got your starting thing there, so if I go over and look at that table and I pick up a squirrel cage motor, come over here for an inverse time circuit breaker, it tells me I can take it at 250%. Well, if I take 65 amps at 250%, that's going to give me 162.5 amps. Well, if I go look at table 240.6a, the next standard size below that's 150 amp. I can go smaller than that, but that's what it is. Now, they've added, and they took it out where it was an exception. Now it's full code text. So now if you go look at 430.52C1A, it automatically permits you, without doing any further calculation, to be able to go up to the next standard size overcurrent device, which I'll look at that in just a minute, is 175 amps. And then C1B says if it still won't start, it tells me there I'm 100 horsepower, 100 amps or less on my motor sizing. So it tells me I can take it at 400%. Well, if I take 65 amps times 400%, that's 260 amps. But guess what it says? It still says you can't exceed the calculated value. So that means I got to drop down to 250 amp. So I just did that real quick, but I'm in between 150 to 250 amp on the sizing of the overcurrent device. That's permitted by code, and we classified in our publications minimum size, next size, and maximum size. That would actually be the maximum size. Now,
so the way I look at it, and I'll try to cover this based on what I hear from you, James, is basically you have anywhere from 225%, your maximum percentage, to 175%, which is your minimum percentage, right? Am I right on that, based on that table, or how's that work?
Well, 250% all the way up to 400%. And what that is, that sizing that they're putting there is to allow for the inrush current in the startup of that motor. So it's really, I understand what he's saying, double dipping, but what it really is to allow the overcurrent device not to trip. And, you know, it's sort of the same thing, like, and I'll do this one time, I'll go through this where we go through fire pumps. It's a little bit different because if I go look at 240.4A, that is where you get into magnets and fire pumps and things like that. You got to have percentages and stuff set in place there to where the overcurrent protection device never trips. Okay? So there's reason that percentages are put in there is to allow that overcurrent device, you know, at a certain level that they've established here to allow that motor to start and run without tripping.
And that is one of the examples in the code book where voltage drop is enforceable.
Yeah, and let me say one other thing. You know, they say, well, it says maximum in the table. Yeah, that's the maximum percentage for the table, but that's not the maximum size overcurrent device. They argued this with me, you know, saying, well, you're calling it minimum. Well, it's a starting point. But I said, let's just take it a little bit further since you want to argue it. If I go over and look at 440.22A, okay, and I'm dealing with AC units, okay, when you go in and look at that, how many times have you gone and looked at a nameplate where it has a hacker breaker rating size, minimum and maximum? Well, the minimum that's set up there is based on 175%, and the maximum's based on 225%. But let's take it one more step further. In the 2023 cycle, what did they do? Well, they come in and now they allow you to go up to the next standard size without even doing any calculation. Well, voila. Guess what that matches now? It matches 430.52C1 that deals with motors. Right. So, you know, are you going to tell me now I'm completely wrong, but the manufacturer's right by using minimum on the nameplate? And then they come back and say, well, not every nameplate says that. You got to you can't win or lose with them. You know, they got to argue.
How did they get that value? What did they use?
They use 175%. I'll tell you what they used.
it always cracks me up when I was talking to your dad about that, and he was talking about when he first started talking about that with NFPA, and the guy who wrote and designed that table was like, that's exactly how I freaking wanted it to be.
Yeah.
That's exactly what I wanted it to say, you know, like that's exactly how I wanted it to be used, and that means a lot, you know, and you know, your dad's been teaching it that way for all these years. Now all of a sudden, 70 years later or 50 years later, it's wrong, you know.
Everybody's wrong because we tell you are. You know, Ron Jackson don't know nothing. I'll tell you right now, I go back to the old school where they were teaching it exactly the way it's been taught for 50 years. You know, they come through and the guy that put that table together, and Dad tells this story, that he wrote that design book and he put that in and laid it out like that. And the guy literally was, they were arguing some points on something when they were working on that. And he brought Dad's publication there in the committee. Dad wasn't even on that code making panel. And they brought it in there and he said, this is exactly what we mean. And they massaged the wording a little bit to match what he had put in there. And I'll tell you something else. A lot of people don't realize this. When they redid Article 250 on grounding, if you go back and you look at our design book, it is almost laid out exactly the way we had our headings and everything in there. They laid that Article 250 out like that and told us they used it, our grounding book, as their template and model on how to write Article 250. That's a fact. That's true. So, you know, when these other guys come in and start, let's see, Double D reminds me of design professor applying 220 optional demand calculating result. I know exactly what he's talking about there. But that there is for a whole service. That's not individually. There's a difference there, because when you're sizing for the service, you're just say I was doing an optional or say a standard calculation. Right. Let's say there's certain rules that are in place, and you'll remember I actually went over 220.82 and 84. If you go in and look at residential calculations that are on the YouTube site, you'll see me go through all those calculations.
Yeah, that's what we thought, David.
That's correct. That's right. And what we're getting into is the individual circuits here. It's sort of the same. If I go over and set a separately derived service, I'm going over and I'm setting that up based for a service, and then the branch circuits are totally separate from that point on. So there are different rules and stuff. Or I could be over going setting a separately derived service and going straight to a motor control center. I could be going to that, and then you got different rules out from there. That is correct. Okay.
True.
Okay, I'm on the soapbox.
Right on. All right. All right. What was that? 230.52 C1 in a nutshell. Kind of.
You know, doing it all these years, and I've been very fortunate because I've been into instruct at some of the biggest companies in the world. I mean, I've been overseas. You know, they
understood a bit of a tangent.
and I've done stuff for the Department of Energy and Defense and ExxonMobil, NASA. I mean, I've been all over the place. And, you know, plus teaching 30 plus years for NFPA. You know, one of the things that is interesting when you were able to do that, NFPA, when I taught for them, we had a lot of engineers that came in. And the engineers, they would come in with some very specific questions. And NFPA, when we used to go to Houston, usually they'd want data out there because those people that were coming in there were from the oil fields. And they had some specific engineering questions that dealt with engineering. And luckily for Dad and I, we had actually gone in and we wrote the inspection procedure report for the pump stations on the pipeline in Alaska and here in the United States. So,
right.
You know, being in that area and going out and looking at everything and seeing the different, because I'll tell you, what we saw in Alaska was totally different than what we saw here in the United States. I mean, because you got cathodic protection, all this other stuff they were doing. I mean, it was something to see. But you learn parts of the calculation.
I might take a little bit of blame for that because I think I pointed out to them that their ambient temperature never rises over 86 degrees all year. So they could do upsize their conductor by 0.4%. So, I might have told them that. I don't know.
I tell this story. I first time I went to teach in Alaska, I was teaching at Prudhoe Bay. And that's up there, there's nothing out there. I mean, it's like its own little city, they bring the food in, you eat there. I mean, there's nothing. They got their own movie theater. You don't pay for nothing. It's just all there. And the first time we come in, of course, they flew me in January. And I remember I was in the plane and I'm looking down and I'm like, this some bitch landing on ice. Yeah, he was landing on ice. It scared the hell out of me. But we got in, and when I stepped off that plane, I swear to God, it was 40 below with the wind blowing. I could barely breathe when I stepped off that plane. I could not get to that building. The bus was cold. And, I was dressed well, but, man, it was freaking cold. And the whole time we're down there, those guys, they were used to it inside. They're wearing T-shirts and stuff, and I'm wearing a freaking sweater. I'm freaking cold. It's 60 degrees inside. 56. It's cold there.
Dude, I have a story with me and one of my buddies. We went to Vegas in the middle of January, and I was all happy. I'm wearing shorts and a muscle shirt, and we're walking around Vegas, and we're going to get on the tramway, and I look at this chick. And she's got a winter jacket on, and she's shivering with the winter jacket on. And I'm looking at her all weird. She's looking at me all weird, But it's just because here in Colorado, we're just used to it,
What you're used to. That's
yeah.
That makes your blood thinner or thicker, depending on the area you're in. All right.
Yep, we got some 2026 coming up for you guys. You'll love this. All the 2026 code changes. Look back at all our previous episodes if you want to get them all.
Something I want to say, I don't know if anybody really realized this. Since the start of the year, we have done the journeyman and master exam prep calculations, and then we started on the 2026 first draft changes. And all of that has been since the start of this year. Every Thursday, we have gone and covered all of this. I mean, that's a lot of topics.
Guess what we have coming up? We have the second draft coming up this month.
Yeah, but they'll see that after we do it with the publication. So,
right.
Because I'll wait till it goes through the standards council and everything, because we'll know the final votes and everything. It's like the last cycle. They were telling me, co-making panel 1 already stated, and of course Ryan Jackson did his mic drop, which I said, you can call it a mic drop, whatever, but when it gets to Standards Council, they're going to reject it because you don't have the technical merit. And they told me, I see there, you don't understand how the code-making process works. You're an idiot, all that. Well, what happened? Exactly what I said would happen.
Dude, there was so much prediction, because they initially set that sunset date, January 1st, 2023, and you're like, no way is it going to happen, and they're like, oh, talking all this, you don't know what the hell. The next thing you know, it was like they were all surprised when all of a sudden the co-making panel's like, oh, it's going to have to go to September 1st, 2026, and then you're like, I don't even think it's going to make it September 1st, 2026, and
I told them if we do anything, it'd be 2029, and they told me, you're an idiot, moron, a dipshit. They called me all kinds of names and everything, and then it happened. They go, we never said that. You're lying. Anybody that's followed these threads know y'all are lying. Golly, dudes.
But you remember, at that same time, they called you King James. So
they did, so we stuck with it.
You got the King James title down.
Go King, go King, go
Dude,
King.
I'm telling you, it's getting around. I went and I had a AI do a little thing for my podcast to do on my audio podcast, and it automatically put you as King James. So I'm telling you, it's getting around, dude. It's getting around, man.
It's funny because I was telling that story, because I go play pool on Friday nights in tournament, and then I got Monday night, we got league and stuff. And I come in, everybody, it's like a joke now. And I come in, everybody calls me King James.
Yeah. Dude, I'm telling you, like,
even people it's not even electricals making fun of them.
we first time ever getting Adam from Team SOS in here, and he's like, "Hey, what's up, King James?" I'm like, "What? Where did you get that?" He must have got it from AI, maybe. I don't know.
Yeah, everybody's just sort of laughing about it now. It's just become a great joke. All right, let's roll topic.
All right, topic.
Before we start, I want to bring something up. I just remembered. I just finished completing from the design book all the brand new hazardous location illustrations. So now what is going to happen is I've already set the files and stuff, and I've got them put up for the hazardous location book. Now, there's probably about 15, 20 more I'm going to have to draw that are more specific, but the main items have already been drawn. So they're looking pretty good. Matter of fact, if you'll indulge me, I want to show everybody what they're about to see in the publications. And I'm going to say this. These illustrations are fantastic. When
I saw that one you posted with that tank, I think it was like a vessel something. I can't remember what you titled it, but that was a good one.
Oh, yeah. Well, wait till you see these. These that we have done here is where you're going to get into like spray paint booths and all of this stuff, and gasoline stations and aircraft hangars. Now, let me get it here. I'll pull it up so everybody can see this. I think everybody's really going to like the work we've actually done on these.
I know your original aircraft hangar one was pretty good.
Yeah, well, they're redone since then. All right. So here, can you see it okay?
Yeah.
There. So this is what the new aircraft hangar is going to look like. We drew the way the lights look up there and everything. And
looks like a C-130 up in there.
Yeah, it was just something to put in there. I was actually going to do it in color and stuff, and I thought I looked at it. It actually looked better in black right there. But we also come in and we showed the different type of receptacles that can be in the area, and the ones where you have them in the hazardous area, what those actually look like. We've completely drawn those. This is where you come into a gas station, and we're showing all the distances around. We even show where you have the vents and discharging down. This illustration actually took a while. It's got a lot of major detail to it.
Hey, is that called a code loop or a code ring? No, I'm just kidding.
That's just called looking at. Then we showed here where you get into your lighting standards and stuff, and showing the distances and everything, how to classify the boundaries, how far out and all that stuff. So
yeah, if there's any other references from other sections, they usually put them in there.
Oh yeah, and we come in, we did the tanks, but check these out. We come in, show you where you get these tank vehicles and stuff when they're loading and unloading here. This is showing where you got an above tank and where you got the dock set up around it and everything, and what your distances are. And nice. Like here, these took some time here.
Lemonhead in the house.
Awesome. Hey, brother. And here's your spray paint booths. We're showing you what they look like when you're in here, where you have them locked and interlocked. And then we show them here where you have an open top at the top, and then where you have a closed top with a hatch. We're showing you all the distances around it. And then this one took a long time for me to draw, but this is what you would see out there where they're coming in and they have a dip tank there. And then they got the drain board, the pipe that comes out to drain it and everything. So we actually went in and showed how these dip tanks work, where they're working on a conveyor rail system.
So that area within like 5 foot of that tank is a class 1 div 1, right?
Yep. And we show all that. You'll see,
nice.
Well, it might be hard to see on the screen, but we actually show where we have everything done around it in a dotted line. And the dotted line goes through and gives you an example of what the distance is and everything. So
nice.
Very, very detailed illustration. And of course, I had to throw a hot rod in there, but we show one here, and this is showing where they have the sealed glass panels and stuff, or the lighting.
So, I don't know if that guy's wearing the right PPE right back there.
Yeah, and then we got the zone location stuff here, a few of that, and then we go into all your zone stuff with all the different type of protection techniques here, and the type of protection techniques that they're going to use for different locations.
This is out of the design book?
This is just in the design book, and there's more that's going to be added to it. Then we go in and show you the markings and stuff on equipment with your T codes and all of that, and give you an example of how to go in and turn it. But that gives everybody a little bit of idea of what is about to come, and that there's a lot of work that's been done. But when that publication is going to be in color with those illustrations, and I'm telling you, that is going to be the best hazardous location book by far that's out in the industry. So you can actually see the way everything looks. And that's just a small example of the illustrations. They go much more in depth and covering everything. So anyway, I hope everybody enjoys that.
That is the most misinterpreted code in the whole entire NEC. Nobody knows hazardous location. Like, everyone's just freaked out and just tries to overkill it. They don't know the actual rules, because when you go out there and you know the actual rules and you say, nope, this is what the rule says, this is why it does it, that's a kind of more what I like about the way you teach, is you're like, you need to know what it says, like that's what's so awesome about it,
I think everybody's really going to enjoy that publication, and I'm hoping everything goes right. That publication will be done here at the end of October, ready to go. So,
nice. Good job, man.
And we're getting real close to. We got the other thing that's going for the learning management system, getting it all set up and everything. So we're hoping here 1st of November, if not definitely December 1st. So we're real close to bringing all the new publications, and then for the rest of the till next year and everything, I'll be working on the design book. Well, no, I'll have that coming up, but the design book will, we've already done about 8 chapters of it of 24. So we're eventually going to get the design book all in color too. So with very detailed illustrations. So all right,
I'll let you get the topic.
No worries. All right. So topic of the week, we're dealing with the 2026 changes. Last week we did a few that were dealing with Article 700, and you're going to see some of the same stuff, maybe a little bit different worded and everything, that is going to deal with your legally required and optional standby systems. And one of the things that I'll point out here that is the main thing is record keeping in D. And you'll see we had that before. They got rid of written and called it record keeping. And they're telling you, just like for these type of systems, just like we do for emergency systems, that you got to have a written record, and it has to be made available upon request of those authorized to design, install, inspect, maintain, and operating the system. And then the other thing that they clarified here is testing under load. and they're telling you that the means for testing a legally required standby system is during maximum anticipated load conditions.
True.
Okay, so
It
there,
seems like a little bit of this change too kind of aligns with 70 B. Uh, so to try to kind of allow for some of that servicing, maintenancing to kind of correlate with the NEC.
right.
If you ask me, that's just my guess, but
Well, the some of it, yes, but I would say not as much.
right.
Because this here is more in direct reflection what you're going to see when we're dealing with these types of, because you remember when we were looking at this and some of the stuff that was happening with articles, what should I say, chapters 1 through 4. They have taken a lot of stuff that was mentioned in chapters 1 through 4 where it wasn't specific. So what they did is they got rid of some of that up there and moved it back here where we're dealing with chapters 5 through 8.
Gotcha.
And that's what's taking place here. And you remember, this is an argument I've had with some of them on the groups. I've said, if you look at the code, what does it says? It says if I look at chapters 5 through 8, it can supplement or modify chapters 1 through 4. Well,
Sure.
if it comes in and supplements or modifies, tells you do something, and then you want to take chapters 1 through 4, something that's up there, and say, well, no, this, you got to do it because it's in it. Well, no, you don't, because these chapters supplement or modify. That's what's taking place here.
True.
Okay? So
I agree.
and that brings up here, because when you look at this, and we had this already in another one where we were looking at 700.5, it talks about if redundant transfer equipment is used, then you got to have a means to what? Disconnect the transfer switch from all supply and load side sources.
True.
So in other words, what does that mean? It means inadvertent parallel operation shall be what? Prevented. That's what they're trying to do. So what happens when you got this? More than likely, you get into and you start looking at your markings and stuff, and you'll need to have that on there to let you know that you have redundant transfer equipment there. You just, you want the person going out there to know. And that's another good reason you want 70E in place here, is where, say I was a contractor that went out to work on this equipment. Well, that's why you want to have a communication between the facility and the contractor. And if there are any other things out there that they're not aware of, you're supposed to make them aware of them hazards. This is a good example there.
Yeah, and I'll take that like a little bit of a step further, just to a real life example. Like we went in on like a Saturday for like a routine shutdown, and they went and killed power and everything, and they're getting ready to go, and it's like, you check to see if the generator started? And they didn't even think about it, and that whole time the generator fired up and ran, and it was running in the emergency mode. Right. So, like, it actually gives you a step-by-step. If you're going to be doing a shutdown, you got to hit the EPO on that generator, you know what I mean, to make sure it's not going to fire up and backfeed your system.
Sure. And there's a lot of things that you look at when you get into this stuff. And I think what they're doing here is tying everything in real nice, because if I'm dealing with emergency system here, if I go look at 700.8, you're going to get the same thing here where I'm dealing with a legally required standby. And they're telling you that when you have this legally required standby system for your switch gear, switchboards, and panel boards, things like that, that the surge protection has to be listed. Okay, same as if I was dealing with an emergency system. And then when I come in, look what they did here. they got in and have the same thing here, that they talk about selective coordination. And when you're going to be doing replacements, and they say when you have legally required standby overcurrent protection devices or normal system overcurrent protection devices that supply these legally required standby loads, and you're going to replace them, well, guess what? It says that you have to reevaluate and ensure selective coordination for the legally required standby system. Okay. So I think that that's a really, really important change, because, when you're going to coordinate something, you've done it, and then you come in, replace it, and don't check it, that doesn't, all of a sudden, it might not be selectively coordinated anymore. So they're putting changes in here that are important to be looked at. Now, another good thing that I like here, this gets into the wiring methods, and what you're going to see, you'll even drop over here to the next part right here also. But what this is getting into is talking about the wiring methods, where I'm going to deal with the identification of DC power source output conductors. Now, if you'll remember, the code actually dealt with this in 210.5, if I remember right, where they were dealing with the DC power sources. And now what they've done, they've moved this over here to be more consistent with what they want when you're dealing with these type of systems. And if you notice, they get in and they talk about the positive polarity, and they talk about what is the identification here. Well, you can have imprinted plus signs or the word positive or pos. That's durably marked on the conductor insulation, or it says an approved permanent marking means. So you could have sleeving or shrink tubing that is suitable for the conductor at all the terminations, connections, and splice points with imprinted plus signs or the word positive or pos on there. Then you get into negative, you get the exact same requirements. And then they talk about in 3, what is the color identification here? And it tells you for non-solidly grounded DC positive conductors, it tells you it'll be marked with an insulation color other than green, white, or gray. Now, what does that match up with? Well, that matches up with just what's required in 200.6 and 210.19. And then if you look
you're
here,
thinking of 210.5, right? Or
200.6 deals with your white and gray.
Oh, got you.
And then 250.119 deals with your equipment ground, which is green. And
right, yeah.
And then if you look, it says in 3 for solidly grounded DC conductors marked in accordance with 200.6. So that's what I'm telling you. When you go in, you look at the color coding stuff, it's matching up with some of the other requirements. And you've heard me say this before. There's only a few conductors that have certain color code markings on it. Basically, they tell you if you have a neutral, white or gray, equipment ground's green. Now, there's some other ones in there when I get into non-intrinsically circuits and safe circuits and things like that, or for high lead marking and things like that. But pretty much all colors are open up after that to use whatever you want.
True.
Okay?
Because didn't this used to just be black and red?
Yes, it did.
Okay.
And they've gone it, well, the code didn't recognize it, but that's what people did. So just to put it like that. And then when you get into,
we got a question come in the comments. That's kind of a good one. That's a good question. How do you remember resistor ohms, colors, and ohms?
I don't know how you remember color for ohms, but when you're getting into the colors,
isn't black
like
zero?
That, well, those right there, I'm assuming he's talking about internal to the equipment, and that's they make those.
Well, no,
decisions.
like so if you look at like a resistor, it has like the color bands on it,
Right,
and each one is like 10K, 5K, whatever, you know.
I never deal with that.
I think black is 0. Like, I
I'd
can't
have to
remember.
go back and look. It's been a long time. I never really deal with those because usually the equipment comes out, it's got everything done. If they're using resistors, diodes, and things like that, and I never have to mess with it.
So I've been doing fire alarm for a while, and what happens, what usually I do is I put my meter on it, and I say, okay, that's a, you know, let's say it's a 47K. Then I go look at what the bands are. It's like one gold, one purple, one red or something. And then I write that down. I say that's 47K. So I kind of make like a little cheat sheet, you know, and I don't actually do the calculation. Like, I think like one band is like 100K, and then the next band is 1,000K, and then, you know, I think they go all the way up to like million K or whatever. But no, that's a good question. So you deal with circuits currently and parallel and series, and it confuses you greatly. Yeah. Like I say, typically, what I do is I just make myself a cheat sheet with the different resistors, and then, you know, try to say, okay, this, you know, this resistor's this color, and then that's equivalent to this resistance, and then I just make myself a little cheat sheet for what I'm working on.
I would
That's what I do.
personally think that you could go online and they'll have a chart of the resistors for the color coding and everything that you could download.
You could go to NEC Code page, and it's on my page. I have the whole chart there. You could.
Yeah, I was about to say that's the way I would do it. That's something I honestly, I just don't remember the colors for all of that.
Yeah, I have the whole entire chart posted on my page. You just have to look a little bit.
Okay. All right. Now, looking at C, let me explain what this is so anybody looking at it, if you hadn't been trained properly to understand what they're talking about here. It talks about grounded conductors at different nominal voltage systems. Now, let me give you, you're welcome, Geebland. Now, if I take, and let's say I come in and I've got a service over here, and let's say it's 277, 480. And then I'm going off of there, and I come over there and I've got a box I set. And then I come from that panel board, I hit a step down transformer and say I got a 120, 208 volt system. And I come out of that panel board and I come up into that box that has 277, 480 there. Now, what you're talking about here is where we have grounded conductors at different voltage systems here. This is where you're going to go over and look at 200.6D to deal with this. Okay. And, you know, my code a long time ago, and I know this 100% fact because I even remember where I was in Dayton, Ohio, doing a class for NFPA on code changes. And they come in with a very specific question because Mike had told them that if I put a white in, then when I had my other system voltage there, I had to have a gray with a colored stripe in it other than green. That wasn't true. And so what they did, they come in and they now got it in a list for you because I think Dad might have submitted this proposal, but he had it in order and you had two options there per 200.6A. So if I had a 12208, what we would do is go over there with a white for my grounded conductor. And if I had a 277 480, I would use a gray. Okay. True. Now, if you want to put one with color stripe, that's fine, but white and gray are two different colors. And what I was told, I wasn't in the class, but he said over time, you couldn't tell the difference between the two conductors. That's not, you can't not make that kind of statement, first of all.
No.
But
let's
specifically state that based on some of the loads I've seen some conductors carry that they had too much load for circuit. I've seen red conductors you couldn't tell they were red. So that means we can't use red now? I mean, you can't do, your opinion on something. Those are two different colors. So now they allow you to go white, gray, or white or gray with a stripe in it other than green. They give you those three options, and they're in that order. And the reason they're in that order because the stripe one is the last one you'll use. The only time I ever see them really use the stripe on the white neutral is where they're going out and they're feeding a whole bunch of computers and stuff, and they got multiple circuits in the conduit so they can separate the neutral because of the harmonic loads that be placed on that neutral for all those computer systems and everything.
True, 100%.
And you'll see.
What up, Cam Dog? Cameron's in the house.
And one of the things you'll see, look at those module units. You see that. That proves exactly what I'm saying. It's not hearsay or my opinion. I'm giving you examples that you can go out and actually verify and see that they do this type of installation. But anyway, I thought that was important to go through that. Then when you look at this, they did the same thing here where they got into the ground fault protection here. And what they tell you is they say, where you have ground fault protection equipment is installed in accordance. Now look here, 230.95 and 215.10. 230.95 deals with the service and 215.10 deals with the feeders. And once you have it on one side, if you have it at the service, guess what? You don't need it for the feeder also. Okay. Right. But if I don't have it at service, I could put it for the power source from that is supplied by that feeder, and that will take care of it also. Gotcha. Okay. So they're just putting something in here for the ground fault protection of this type of equipment to help take care of that, where you have these interconnected sources. All right. All right. And let's see what else I got. That's all of them for this week. That's quite a bit.
Great job.
About 30 minutes.
Yeah, it means a lot. Do you want to just roll the Willie quiz since we got Cam Dog in here?
Yeah, we'll roll it.
All right.
Let me cue it up here. I hit the wrong one. Here we go.
Oh, dude, that's so awesome. Thanks so much, Adam, for that awesome intro. Dude, we have
Adam is here. Let's see. Is he here?
Oh, there he is.
I'm here. I made it.
Just waiting on you, baby.
Awesome. Welcome in. Got the big W for Winnipeg not win, huh?
I got the W because I'm going to win.
All right. Well, Adam actually is probably second place to Daniel, so he's got a couple wins in here. And like I say, my only advice is a really easy quiz. Just don't copy King James, because even if he thinks he knows him, he might not. So
we did Monday. I only got 2 of 5, but I still won.
Yeah, true. So you do have a chance, Adam.
Sounds good.
But this is a continuation of our quiz from Monday, which is undrafted NFL players. So question number 1, which undrafted running back has been inducted into the Hall of Fame? A, Priest Holmes, B, Adrian Foster, C, Emmitt Smith, D, Marilyn Motley, or E, Malcolm Butler. Good luck, everyone.
Well, this is interesting. I know Emmitt Smith's been inducted, but he was actually drafted. The one I know 100% fact that wasn't drafted was Priest Holmes. And the reason was he got hurt. He was a running back for the Texas Longhorns. and he
Right.
got hurt, and that's why he was undrafted. And of course, who took over for him when he got hurt was the great running back Ricky Williams. And
Oh,
yeah,
yeah.
I do know
Oh,
this.
dude, Daniel
That's what
comes
I was
out
going
with.
with. I think it's Priest Holmes. But if he was inducted into the Hall of Fame, it was just recently, and I wasn't aware of it because he's actually inducted into like their Hall of Fame for Kansas City. So I'm gonna go with A on Priest Holmes too. But I know he for sure. I know he was undrafted, and if anybody deserved to be in there, it's him. He kicked ass in the pros.
True. All right. Well, it looks like King James copies Daniel's answer tonight, which is pretty rare. If King James is copying Daniel, I don't know. You have to question it there, Adam. I think you have to question it.
So I think if King James is going to copy Daniel, then it only makes sense if I copy King James. Keep the ladder going. Keep the ladder going.
Oh man, you guys, man. So if there was a second answer that you would decide to copy each other on, what would you pick?
Wasn't
I'll
Priest
pick
Holmes,
A
so-
again.
Well, Emmitt Smith, I know he's in the Hall of Fame, but he was drafted.
Yep.
I think Arian Foster was drafted too, because
Yeah.
Arian Foster was running back for the Texans.
So the only possible answer you guys would have had is D, Marion Motley, and he was from I think the 30s or 40s or something. Just barely got drafted. So
That
I
would
just
be
tried to-
interesting because, I've got a question on this because what are we considering? Because in the 30s and 40s, didn't they have like 20 rounds or something of drafting?
Well, he was undrafted,
Really?
so he wasn't drafted. So he was one of the undrafted players that just got added to the Hall of Fame. So
Okay. All right.
I got you. I got all you.
Yeah.
Yeah.
Okay.
All right, question number 2. Which undrafted defensive back became famous for his time with the Oakland Raiders and was inducted into the Hall of Fame in 1984? Was it A, Ken Houston? Was it B, Mel Blount? Was it C, Willie Brown? Or was it D, Lester Hayes? Good luck, everyone.
Got the wrong one.
So the reason I like these is because it takes a lot of years to get them into the Hall of Fame, you know?
It does, and I know it's C or D, but I'm trying to remember which one was famous first time over. I think Lester Hayes was with Pittsburgh, if I'm not mistaken.
Yeah, I think he got traded to the Raiders at the end of his career.
Yeah, I think it's C. Willie Brown. I'm gonna go.
I was
with
going to
C.
say C too as well. Really, because I thought I heard something once. So yeah, I'm going to go with C as well.
Oh man, you guys just freaking go copy Daniel. But luckily you're correct. It is C. Willie
Yay.
Brown.
So I was right. Lester Hayes was with Pittsburgh, and that's later because he wasn't famous with. Okay, that's what I was thinking. All right.
All right, so everyone gets the correct answer. We got
All right.
1 and 1 so far. All right, question number 3. The undrafted linebacker holds the NFL record for the most career tackles, but has not yet been inducted into the Hall of Fame. Who is he? Is it A, Zach Thomas? Is it B, Ray Lewis? Is it C, London Fletcher? Or is it D, Brian Urlacher? Good luck, everyone.
I'm
Well,
gonna
this-
Alright,
go.
so everyone's Google searches have ended. So
Well, I know Ray Lewis and Brian Ertlacher were both inducted in the Hall of Fame. I know those two were. And Zach Thomas, I don't recognize that. Now, London Fletcher, I do recognize, and I don't think he was ever in the Hall of Fame. Zach Thomas was probably somebody from like the 30s, 40s, or 50s. I didn't know. So
Right.
I'm going to go with C, London Fletcher.
I should have had
Everybody's
more E
listening.
answers.
Is he right on this? I'm just guessing on that. It's A or C because I know the other two definitely are in the Hall of Fame.
All right, Adam,
50-50 chance.
are you gonna go for the copy?
I think I
King
am.
James.
I think I am.
All right, you both copied Daniel, and you're correct.
Yeah.
It was London Fletcher. So I should have more E answers. Dang it! I dropped the ball on the E answers, but I sometimes move the right answer to E, and I really get you guys. But
All right.
well, we'll get it next time. All right, which of the following undrafted wide receivers was Super Bowl MVP and is in the Hall of Fame? Is it Julian Edelman? Is it Hines Ward? Is it James Lofton? Or is it Don Maynard? Good luck, everyone.
Oh, this is one I'm going to have to think about here.
Yeah, it's a little tricky.
Uh,
Dude, Daniel's just going crazy tonight with the C answers. James Lofton.
see,
That's
that was my
that's like-
first initial one was James Lofton. I know he was undrafted. Hines Ward was drafted.
yeah.
I don't know who Julian Edelman is. I do not. Don
So,
Maynard, he was in the
Edelman-
30s, 40s.
Edelman won the MVP with the Patriots. I can't remember what year that was. I want to
But
say
I
it was
don't
like
think
13.
he was a Hall of Famer, though. Lofton, I know, is a Hall of Famer.
I'm gonna
So-
go with B. I think Hines.
Hines Ward.
Yeah.
I think he
All
was
right.
drafted, though. Hines Ward played for Pittsburgh. And
Yeah.
I'm going
I
to go
think
with
he
C.
did.
I think it's Lofton. I'm guessing at this one.
I think Hines Ward did get the MVP with Pittsburgh when they beat the Cardinals that one year.
But I don't think he's a Hall of
Because
Famer, though.
wasn't he the one that had that tiptoe catch in the back of the end zone to win
I think
the
that
Super
was
Bowl?
him.
Yeah.
But I'm going to go with C. I agree with Daniel on this.
I'll go with B. I'm gonna try not to copy, so I'll go with B.
All right. Well, Adam did a great job to not copy, and King James wants to copy Daniel, but everyone is wrong. The answer is D. Don Maynard.
Almost, I said C or D. I was like,
Yeah.
Yep. So awesome. I'm getting you guys full a little bit. So we only have 2 correct answers so far, which is awesome.
damn.
Question number 5. Which undrafted defensive player won 2 NFL Defensive Player of the Year awards and was inducted into the Hall of Fame in 2023? Was it A, James Harrison? Was it B, Sam Mills? Was it C, Charles Haley? Or was it D, Ron Woodson? Good luck, everyone.
Well, this is interesting one. God, I know all four of those, but two NFL defensive players. Sam Mills seems like the right one to me. If I was going between two of them, it would be Sam Mills or Rod Woodson.
With two
Yeah.
NFL Defensive Player of the Year awards.
Harrison and Haley were good too. I mean,
I think Rod Woodson had like 7, didn't he? Like he had like a bunch. Yeah, more than 2.
I will go with A on this one.
Harrison's a good one too. I'm gonna go with B. Sam Mills. I don't know why. Some reason I think it's him.
Well,
I know
Adam
he's
is
in
going,
the Hall of Fame. So
Adam is going A for Adam, and Daniel J is correct. And King James copies him, and it looks like Daniel takes the win with the tie with King James tonight. So, oh man, what a good match.
Nice.
That was so much fun, but yeah,
that's all right.
Correct.
Damn.
Sam Mills. So, looks like King James is doing a little bit of copying tonight, but like I said, it was an easy quiz. It was easy. I'm trying to make them easy for everyone.
Fair enough.
My answer's first, and I'm copying.
No, Daniels was first. I have a timestamp on here. It actually has a PM. Like you could look at the comment, it gives you a PM. It said his answer came in at exactly. Yeah, so you were late. You were late on that. But the whole thing is, it's really awesome, Adam, that you come and join us. And like I said, we love hanging out with you.
Appreciate it.
It's a lot of fun, and even if you don't know the topics or whatever, like we're gonna do Bible again. We got to do Bible again because I don't know, dude. I think you and King James are pretty even on the whole Bible thing. Like, dude, King James went 5 for 5, and I couldn't even get no. I tried to do a tricky one. I couldn't even get none over.
I was giving background on it. I was like, no, I didn't write. I was explaining it all. I was like, no, this is.
This is what happened. This is what happened in Deuteronomy, and this is the book and everything.
Before I give it the answer, it's like before I give it the answer.
You finally got that background in. Dude, King James has a cool background. He tossed in.
Yeah, I got the lightning going off in the back.
Yeah. Before I give you the answer, let me just break down each 4 options why these 3 are wrong and this is the right one.
Yeah. It was vulgar display of power. It was not even funny. And then Ann was getting ones wrong. It was so cool. Ann showed up, and she was getting ones wrong, and she was at the Bible study. You know what I mean? It was pretty funny.
Yeah, I forget exactly the first question, and I said, oh yeah, those. I quoted all the books off and everything. I said the one that's missing is Numbers. I said, so Joshua's not it. And she come back, she goes, yeah, the last ones were on Mark. I said, that's correct. So
yeah. No, Ann did get, I think she went 4 for 5 and you went 5 for 5, which was pretty cool.
Yeah.
A lot of fun. But we're going to keep rolling. Adam, you're welcome to hang out. We're just going to do the tour review and stuff, and we'll probably go another like 15, 20 minutes.
All right, sounds good, guys.
Let's roll you.
It's time for Tour Review of the Week. Sponsored by Electricians Only Tool Review and Nipex Tradesman.
Well, I really like how you said you were going to roll me in, because this week is a really cool tool that I was just using, and it's a digital measuring wheel. And this is really nice for when you're trying to lag off cables. This is the digital model, which I'm probably going to see if I can find a way to get me one of these, because I want one. Like, it folds up really compact. You could fit it in a really small spot, and then you could extend it out. And what I really like about it, it's got that standard 12-inch wheel on it. and it's got the stand so you can measure out, then you could stop it wherever you're at. You can go get marks or do whatever you want to do, and then you could like continue measuring. These work really nice for when you're doing a lot of cable pulls and you want to know exactly like your production per day. You can go out and say, hey, we're pulling 3,000 foot a day or whatnot, and it makes it nice, makes it easy for us out in the field to accurately track our production, especially like our crew production when we're doing our large wire pulls. We're pulling 30,000 foot of cable a day sometimes, and this makes it nice because you just measure out your overall run. Then you factor in how many the guys got done. Then you factor in how much they got strapped back, how much zip ties they used, all that kind of stuff. And especially if you're saying we're doing one set of zip ties per 2 foot, then you could just use this to go out there and say, all right, we have a 400 foot run. We're gonna use one zip tie every 2 foot. Just do the math, and then what kind of zip tie order you need. So these kind of tools kind of make us better as leaders and foremen and takeoffs, and just to kind of help us out, get a feel on what's going on in the job and stuff. But like I say, this is a really good tool. This is the digital model. The one I used was just the regular rotary model. I really like Milwaukee products, and I really trust them, and this would be one of the tools that I trust from Milwaukee, that I know they've done the testing and that you can go out in the field and it's going to work and it's going to do everything you need it to do, and it's going to be accurate because it has a 12-inch wheel. Like, how can you go wrong on a 12-inch wheel? Every single rotation's 1 foot. So
that's pretty good. All right.
And it just works. But yeah, that's my tool I really like this week. I told everyone I was gonna run it, and I like it. So
how do you like the new?
I might get you on this. I might get you on this question, bro. You never know. This might be a little bit of trickery this week. You never know.
All right, let's see what you got. Let's see, where the manufacturers are short power researchable at 5 for 10. Oh, shoot. It's C or D. God, let's see, that's like 555.3. I'm just running through my mind. So if I went, probably go 1 through 4 at 100%, and then you probably go 5 through 8 at 90. I'm just guessing here. I'm not going to look it up, but I'd say you're probably 10, probably C, probably 80%.
Probably, huh?
Yeah, I'm just guessing.
All right. Well, you're probably correct. It is 80%, but it's funny because everyone thinks it should be like a rule of thumb, and I got a lot of people. But
I will tell a story on this real quick. So, when I first became chief electrical inspector, City of Grapevine, we had to go out, and we had 2 marinas out there that the Corps of Engineers used to look at and take care of and stuff. And then they just didn't want anything to do with it anymore. And this was Grapevine Lake, or Lake Grapevine, whatever you want to say. So they sent me out there, and I started looking. Well, they've been there a long time, and they eventually added on, and of course, boats become better and everything. They started having shore power, and of course, when I went out there and looked, they had the main area. Then they would go to the boat stalls, and they had the underwater cables. And they would go from one point to the next, and they'd have a panel board at each one, and then feed all the different boat stalls out that way. And I went out there and I was looking at, and the conductor was the same size. I actually took the panel board cover off and looked. And so I started doing calculations just in my, what I knew at that time. And so I wrote them up for a whole bunch of stuff, but I told them I'd get back with them on the the conductor size, and I thought it was too small. Well, I called Dad, and I went and had dinner with him at night, and I did a whole thing, and I had a schematic. I was out there all day drawing how many receptacles, how many were shore power, and that was the first time I was exposed. And I remember at that time, I think it was 555 point or -3 at that time. And there was actually the multipliers you could put on there based on the number of shore power. Well, even after I calculated the conductors out there to the furthest one, probably all the way up to like 7 stalls, was too small. So I wrote them up on it and everything, and they hired an engineering firm, and they were going to sue the city. And of course, we had the mayor and the city manager, assistant city manager, director of community development, the building official was all there, and their engineer was going over it and everything. And I said, well, now if you look, and I'll never forget, because I was young at that time. I was probably about 26. And he said, look, son, he goes, I think it's impressive. You're trying to impress your senior management. He goes, but you're speaking about something that's out of your league. He goes, it'd probably be best you just sat there and shut up. He literally said it almost identical word for word. Well, I'd already called down the state, and he told me this was an accepted practice in the state of Texas. So I took and I called down to the state, and I think his name was Jesky, if I remember right. And I was telling him what I was running into, and he told me he goes, no, that's not correct. So after he told it, and I said, well, I'll tell you what we'll do. I said, we'll send this down to the State Electrical Engineering Board, and if they say what you say is correct, and this is an accepted practice, I'll go ahead and I'll pass this. And their attorney, right at that time, he goes, that sounds fair to us. And as soon as I got that okay, I said, but let me make it clear. If I send it down there and they tell me this isn't an accepted practice, I said, I'm going to move to have your license suspended for the next 2 years. I said, do you understand that? And their attorneys, yeah, that sounds fair to us. And then he goes, before we send those down there, he said, let me take them back and, make sure the calculations are correct and everything. And I said, yeah, I think that'd probably be a good idea. And then from that point on, they were like, whatever Dave says in the city, we're going to do, because I shut them down right there. But my dad's the one that told me what to do, and that's how I learned how to do it. So that was my first experience about the percentages for derating for shore power for your question this week. Isn't that something? Something that happened when I was, 30-something years ago, was based on
and that. It came out of your code change book. So.
Well, of course it did.
But that's pretty awesome, and like I say, I'm just, whenever you get a chance to get back with me with those code changes you owe me from 2020, it's perfectly fine. You could do like free software, any kind of like free stuff. You could send me like the free key to stuff. However you want to do it, it's fine. I know it's only like 14, 15 code changes, but what I mean? It's just...
You're never getting them. Hell with you.
Oh, you know what? I forgot the pickle shot. We got to do a pickle shot for Adam. There's a pickle shot to Adam. Thanks for joining, Adam. Appreciate you, brother. It's pretty badass.
He come prepared tonight, folks.
Yeah, got my pickle shot. So, pickle shout out to you, Adam. Badass. So cool when Adam jumps in, and like I say, he's such a great person, and he's such a good sport when it comes to the quizzes. Like, he's like, I don't know any of this, but he still shows up. So it's really cool. And like I say, Daniel, you're lucky because I just changed the rule to tie goes to our guest. So anybody in the chat wants to tie King James, you don't have to beat King James. You just have to tie him. You get the win if you're in the guest spot. So new rule I had to make up, and like I say, dude, you like, I don't think you've done anything since then, since I made the new rule. So
I got 3 to 5. That's not bad.
Oh, dude, Daniel, dude, I can't wait till Daniel's podcast comes out. I guarantee Daniel's got a podcast coming out about it. What it is King James is going to come out with a podcast about Daniel that he made me change the rule to tie goes to the guest, and then that's how it's rigged is, so we'll see. It's going to be
that's going to be the name of my podcast, Rigged.
There you go. Dude, I should just go make one right now called Rigged and then just start doing all our Willie quizzes. But no, it's really awesome. Thanks for popping in too, Daniel. Means a lot, and I'm really excited, man. I think the Broncos can win at home against the Raiders, so we'll see. It's gonna be an interesting game. If our defense plays good, we got that in the bag, but
we'll see.
We'll see. Dude, our defense all of a sudden went to like 10 points in fantasy, Like our defense hasn't been over 5 all year. Now all of a sudden they're at 10, Dude, hey. Dallas is at like 7 still or 6 or something,
They got a lot of new players. Dallas is going to be fine. We'll see how they do. I mean, I don't even know if they play this week. They play Sunday night, so I'll be watching it Sunday night because I'm going to play golf Sunday and Saturday. I'm just going to be. There's no big real games on. I think the biggest game is Missouri and A&M. And
did you hear that, Daniel? Dallas gonna be fine. So
that's right.
We got the official word from King James. Dallas
we
gonna be fine.
Got those 2 losses out of the way for our run to the Super Bowl. I mean.
Dude, the whole thing that's funny is the Cowboys haven't had a single decade since the 90s, but this is their year,
We'll see how they do. I'm sort of bored this weekend because Texas ain't playing. They got a bye week, and Ewers will be back for OU. So Bucks there we go. That's right. You hear that, Bill? Shouldn't have stuck with Atlanta, trying to tell you.
Yeah, dude, I had David Englehart, King James, and Daniel against me, but somehow, like I say, I just like to take the underdog in every match. But like I say, at least I admit it, and
you're gonna have to pick it up. I only hang with winners, baby.
Yeah, probably. Like I say, I don't just copy other people's material. So see, there we go.
Yeah, well,
dude, what was so funny?
We've been copying it for 50 years.
Freaking Weed Man was sitting there saying that my podcasts are made up of mostly stolen sound bites from other people's podcasts. I'm like, really? Mostly? We just went almost 2 hours, and I don't think we had a sound bite from anybody's podcast in this whole entire episode. I was like, yeah, sometimes I throw them in, but, I was like, oh, okay, dude. I was like, whatever.
Whenever we've done sound bites and stuff, it's because of something that was said, and we're showing this is what they actually said. And we're proving exactly what we've been saying. I mean,
to double down on that, all these guys, they know what we're going to do. So they say, don't listen to these guys. If you don't hear it straight from my mouth, don't believe it. So then we go show it exactly straight from their mouth when they said it live on the air. Right. And then now we're still not telling the truth.
That's right.
Dude, when Tommy D sat there and said the GFCI requirements are in 625.54, he was 100% correct. If you go look at it, the standard, it's so funny, sitting there listening to Paul's podcast, he's like, oh yeah, not all EBSE chargers come with built-in personnel protection. That's garbage. Dude, the standard requires it.
Mm-hmm.
It says it right in the standard, and then it says this standard requires personnel protection for the input and output of this device.
That's right.
You can't get any more straightforward than that. And so they can't even get a listing on that unless they provide personnel protection. Now, if that's 20 milliamps, that's compliant with the worldwide standard. What's the worldwide standard on milliamps for personnel protection?
Well, I don't know
Worldwide.
what the worldwide is.
It's 30 milliamps.
30, I didn't know what the worldwide was.
Yeah, so basically the whole entire world is 30 milliamps. The U.S. is 4 to 6. And I mean, that's fine, that we have that increased standard. But everywhere else in the world, their stuff works. Ours doesn't. You know what I mean? So we might have to have an impasse on that and maybe move it up to 20 or something. But
I'm sort of waiting to see what they say on 110.3b that I put in there. The NEC overrides the listing and labeling.
It's going to be interesting. It's going to be, like, they have a lot of problems. I mean, the thing is, like, we're not trying to make them problems. We're trying to just get the clarification so we know exactly where it's at. Because they're like, oh, it's implied there's an outlet there. But you didn't put outlet in the definition, and you're still saying there's an outlet there? Like, to me,
it's
that's
implied.
Where
is the substantiation that says it was implied? I hadn't seen it.
Yeah. Yeah.
So, all right.
Dude, we have a lot of public comments out there. It's going to be interesting. We're going to get a lot of answers for 2026. And it's funny because I've listened to Mike Holt, Ryan Jackson, all the, Mark Early's a good guy. Corey Hannes, Dean, all these different people that are with the NEC. And what do they say? It usually takes about 2 cycles to get a code change.
It does.
Like
Sometimes it takes longer than that.
If there's a code change that is not good or something, it usually takes 2 cycles to get it out of there. Or if there's a code change that's good, or maybe good but not worded right or something, it takes 2 code cycles to get it worded right, Yeah. So all this stuff, like when I hear those comments from Corey, like Corey Hannes is like total stud. We'll give him a hook of horns. Give Corey Hannes a hook of horns. But like Corey Hannes says, they don't always get it right,
Oh no.
So he says, sometimes they don't get it right and they have to go back, and he goes, that's part of the code making process, and we agree with it. We agree with making the code right, making it, but you can't just sit there and tell me that there's just this outlet hovering everywhere outside of every freaking piece of utilization equipment and it needs protection for personnel, because my problem with it now is all of that hazard was based on a metallic enclosure, and now all the new equipment that's hardwired utilization equipment is non-metallic. So, a human could touch that screw or something that's bolting the plastic on or something, but you know what I mean? Like, it's just way reduced. Like, all of this equipment's like been designed for safety, been designed for like lower amperage, higher efficiency, less personnel contact, everything. So
you want
to
hear something interesting I found as I was doing the hazardous location, and I was looking for explosion-proof motors and stuff. They actually had a thing, and I found this interesting. Right where the motor comes out, you had like this little threaded pipe that come out, and the conductors and everything, they were sealed. And then you had the conductors hanging out, and then they had a thing that went with it that screwed on there. And guess what the outside of it said? Outlet
termination.
Box. Outlet box.
Oh, really?
Yeah, I was like, oh, wait a minute. Why is it called an outlet box? I thought it was just a box, Sure. I just saw that. I was like, okay, well, that just sort of proves another point right there. They didn't, why do you have to call it an outlet? They argued with me. If I go up there and I have, say I have an octagon box up there, well, when does it become an outlet box? When it's feeding an outlet. Otherwise it's just a junction box. Sure. And they're telling you they're making
or when
it's
feeding utilization. You're saying where it's feeding utilization equipment.
That's right. It's feeding an outlet. There's utilization equipment there. So you got
But
an
the
outlet.
utilization equipment's not the outlet. That's what the
Oh
problem is.
no, I didn't mean it like that. But what I'm
Yeah.
saying is, the box is the outlet, just like it is right there at that motor, and they specifically call it that, and there's a reason behind it. But I was going to post it, and I was like, I'm not even going to argue. I got too much other stuff going on to be.
Well, send it to me. I'll throw it in there.
Okay, I'll send it to you.
All
All right. Let's see. We got
Wall of Shame.
Shame. Shame. Shame. Shame. Shame. Shame. Shame. Shame.
Oh man, you're gonna love this one this week. When I saw it, I was like, all right, this is a good one. Just straight melt.
Damn.
So this was posted by Justin Marceau. But anyway, so this one's kind of interesting because a lot of times they sit there and say, "Oh, this is because of backstabbing," and like I thought it was really funny because you could see like one part of the terminals is like still like almost in the wall, still kind of up. Like,
Yeah.
Like I thought that was pretty funny, but to me, honestly, I would say that this receptacle already outlived its lifespan. I'd say it was probably designed for 20 years, and that's probably on 25, 30, probably.
Yeah.
You know, so a lot of these, I think backstabbing gets a really bad rap, just because it's not because of just the backstabbing practice alone. It's because the age of the devices, some of those terminals weren't listed for number 12 gauge. There was a big thing. That looks like number 14 to me. It could be number 12, but this could be one of the ones that wasn't listed. It just goes to show you that, like, I love these wall of shame pictures, but you cannot just blame that on backstabbing.
No, you can't just blame it on that. I agree. All right.
So they're interesting, but
How do you like the new
I guess
background?
Dude, that's dope, man. I love the lightning, like the way you got it set up. The only thing is that you might lose the internet if you run it too much over there in Texas.
We're doing fine right now.
So, I just gave you a warning. You never know, you know. Like,
It's interesting. We just keep adding little features here and there and make it even look better every time we do it. So
yeah. Well,
All right.
no, I had a really good show. Thanks so much, Cameron, for popping in. Thanks so much, Adam, for joining us on the quiz. Thanks so much, DJ. See you on Sunday for the game. It's gonna be a fun time. And like I say, thanks David Englehart for popping in. Really love the comments. He has some great comments to add to our topics and everything. So means a lot. Thank you so much, everyone. And as always, remember, make every day an easy day.
Amen. Everybody have a good weekend. We'll see y'all, some of y'all Monday and some of y'all next Thursday. All right. Peace.
Deuces.